Okay, the F statistic is the test statistic that we use for an ANOVA test. So this is different, again, from everything we've done so far. We've done proportion stats and found Z's. We've done T statistics and found T values. So we now have F statistics. So your F is calculated technically by taking the variation between the groups and dividing that by the variation within the groups. Now StatCrunch is going to calculate that value for us, but that is kind of where it's coming from. It's possible to calculate it by hand, but we're going to use our technology. So it's very different. The F statistic and the F distribution is very different from the Z and the T distribution that we've seen before, because it only allows for positive values. So Z's and T's can be either positive or negative, but the F's can only be positive, and it's usually not symmetric. It's usually right skewed. So when we find the p-value, we always use the area to the right of the observed test statistic. So we've got some visuals down here of what F distributions look like. So it says if the variation between the groups is large compared to the variation within the groups, F will tend to be a large value. And a large F statistic discredits the null hypothesis and leads us to a reject the null scenario. So again, if your F value is large, so this is 0, and if my F value is very big, it's way over here, then remember what that means is that means there's a small p-value, and small p's lead to rejecting the null. If the variation between the groups is small compared to the variation within the groups, then F will tend to be a small value. So a small F value follows the null hypothesis, and this would be a fail to reject situation. So if F is a small number, if F is way over here and it's a very small number, close to 0, then there's a whole lot of area over here for that p-value, and large p's lead to failing to rejecting the null. So we always write down that F value, but just like everything else that we've talked about so far in this course, the F value is not what determines our conclusion. The p value is what we ultimately look at to make our decision. So this is all still the same. If p is less than alpha, we reject, and if it's greater than alpha, we do not reject. And an important note to make down here is that there are conditions that we have to check in order to use this ANOVA test. So that stays constant throughout this whole course as well. So far, or what we're going to do in the next couple questions, is we're going to assume all the conditions were met and the test has already been run, and all we're doing is looking at the results and practicing interpreting the results. When we move on to section 11.3, we will actually start checking the necessary conditions, and we will run full ANOVA tests on our own. We're just not quite there yet.